Hey guys, I'm Vishal. Now let's start the problem map from Codeforces Round 697 Division 3, the odd divisors. Okay, so in this question, they are particularly asked that they are given a number n, right? And we have to find that if the number n having any odd divisor rather than 1. Okay, so if it is having a odd divisor greater than 1, then we have to print yes, otherwise we have to print no. Okay, so let's check how to do that. So they are given us a number n, right? So if you think any number greater than 1, any positive number, it having two divisor, right? 1 and the number itself, at least two divisor, the 1 and the number itself. Okay, so if now the condition came, if n is equal to odd, okay, n equal to odd, then we get an divisor, odd divisor for that number, right? N itself is a odd divisor. So if the n equal to odd number, then directly we print yes. Okay, now if the number is even, the problem comes here. If the number is even, okay, we are given an even number, then what we should have to do? So we know that any number we can write in the form of prime factor, right? P1 into P2, P1 whole raised to something R1, say P2 whole raised to R2, P3 whole raised to R3. Okay, dot 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 dot. Any prime factor, we can write any number in the form of prime factors. So we know that prime number, only 2 is even in that. Other prime numbers are odd, basically, right? So we have to check whether the number having only the prime factor 2 or it having other prime factor other than 2. Okay, so if it is having other prime factor other than 2, then the answer would be yes. Okay, otherwise no. Means if it is only the prime factor of 2, then the answer will be no. Okay, so let's check how to do that. We'll drop that. Okay, how to do that? So we know that the range is given, sorry, we know that the range of n is given is 10 to the power 14, right? So what we basically do first, in before doing the questions, we make a vector, or you can make a unordered map also, or hash map, unordered map, and we save all the what powers of 2. Means we save 2 raised to 1, we save 2 raised to 2, we save 2 raised to 3, we save 2 raised to 4, dot 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 dot, with up to 2 raised to 64. That is enough, right? Because 2 raised to 64 itself is 10 to the power 18 approx. So up to 2 raised to 64 we save it. Okay, so basically those are the even numbers in which we don't get any we don't get any prime factor, odd prime factor. Okay, so now other than that, all the even number will having a odd prime factor. Okay, so we basically save those numbers in a unordered list, and whenever they are giving us an n, user give us an n, we will check whether that list contain that number or not. If suppose they give n equal to 4, okay, so in this list n equal to 4 is already exist, right? So for that the answer will be no, because it is only having the prime factor 2. No other prime factor is present in 4, right? So now if they are giving us 6, right? 6, it having prime factor 2 into 3, right? 2 and 3 we have prime factor. So 6 basically you can see there, means 6 is not present over here. So for that 6 it will be yes. So that is the logic we have to follow for that. Means we have to first store all the values of all the factors, sorry, not the factors, all the powers of 2 up to 2 raised to 64 in a unordered list or unordered map, whatever you say. And then we have to check whether if we get the n, we have to check by putting n in that unordered list, if it is exist or not. If it is exist, then it will be the no, answer will be no. And if it is does not exist, that means at least one or divisor is present over that number, so answer will be the yes. That is the logic. And I will give my solution in description and the question also. And please like, share and subscribe our channel. Thank you.